Again, relatively straightforward problem here, which is why I was shocked. But again, car 7 meters per second approaches a 30-degree ramp on top of a table 2 meters tall. I would like you to tell me where the car lands. So in a few minutes, I'm going to wander around the classroom and see what their answers are. And of course, I'll have to have you guys hold yours up to your screens or your cameras so I can see what your answers look like. All right? This is practice. So give them a shot. Let's step through this problem. Perhaps we can identify where our mistakes have been made, or maybe 6.5 is wrong. I'm willing to accept, when I was wrong. Of course, we did this in a fourth period, so I'm pretty confident in this answer. But let's try it anyways. So I'm going to start out quite simply by, organizing myself. Not because I think this is the only way to do it, but because not everybody can just do the whole thing in their calculator. So vertical, horizontal. And delta y, what am I going to put there? All right, I'm going to put 2. I'll deal with negative and positive later. You guys are all in such a hurry. Vy naught, what am I going to put there? 7 sine 30, or 3.5 meters per second. Question? Good? Because not all of you got 3.5, even though you typed in 7 sine 30 because you never changed your calculator from radians to degrees. Look, I'm not gonna sugarcoat this. We use degrees when there's a degree symbol. So you need to know that. Your calculator can't figure it out. Acceleration, we're using 10 meters per second squared. This isn't mastering. But if you use 9.8, fine. Interesting question. If you use 9.8, should your number be bigger or smaller? If you use 9.8, is your gravity pulling down harder or pulling down with less strength? Less strength, so you should be further away. So let's not start with the whole, I did 9.8, that's why my answer is wrong. It's highly unlikely. Since the only difference between 10 and 9.8 is 2%. We should only see a difference in 2% of your answers. And that's not very much. So in this case, if it's 6.5, 2% of 6.5 is like 0.1 meters per second. So I don't want to hear about the 9.8 thing. And time. I don't have to worry about final velocity yet. Now, there is more information given. I know the horizontal velocity because that's 7 cosine 30 degrees. And what's that going to be? Like 6 point what? 6.06 meters per second. All right, so I think I have all the given information. So let's consider up and down for just a moment. Do you want up to be positive or do you want up to be negative? All right, so if up is positive, then delta y is negative, Vy naught is positive, A is negative. Some of you made the mistake here. Or at least it played out here because you needed to figure out how long it was in the air for. And there are a few of you who, in the computation of this part of the problem, made your mistake finding t. There should be 2 values for t. So let's see. Somebody at home, give me one of the values. Or somebody in the middle of, a drive. Go ahead, Amanda. What you got?
1.07.
1.07 seconds. Anybody else get 1.07? Good job. All right. So somebody in class, give me the other time. I want the negative one. Go ahead. Negative 0.373. Excellent. So now I have both of the times. I have verified one is negative, so I can throw that one out. I'm going to use the positive one, which leaves me with range equals 6.06 times 1.07, which is going to give you what, about 6.5 meters. So there's a lot of other numbers there out in the room. I am hoping that you either A, found your mistake, or B, you've recognized about how long I think it should take you to do this. Some of you would have gotten to the answer, but I stopped you before you could finish. Now, I don't expect everybody to be able to operate at the same speed. I'm just telling you that if you are having more difficulty, then I would encourage you to practice a little bit so you can get this part down. So you're not having to think about it too much. Because this isn't the stuff I want you to do. However, I will stop right now and ask, does anybody need me to review this further? Good, so I can probably give you a more complicated question and see how you guys can do on that. Because what I'm going to ask next is really not that much harder, but I want to see if you can combine the stuff we talked about last week and the week before with this. So I'm going to ask for 3 follow-ups. These are not new information to solve for these, by the way. I do not, you should have all the skill set to do this. I want to know max height and where along the ground that is. I want to know the speed that it hits the ground. There's a variety of ways to get that answer. But there's only one way to get this one. All right. 3 different things. Now, for this part, I'm going to encourage you to talk it out with some people around you. Not that you weren't doing that for the last part, but for this one, I think you probably should. For you guys who can't see and are trying to see what's up there because my big head's in the way, I will happily remove my big head for a minute so you can kind of see what's there. Joey's asking us which max height we're trying to find the height of, Mondo or Hall. Ba-lump-bump-bump. Thanks, Joey, for lightening the mood. So, you guys at home, break you up into a couple breakout rooms, or do you think you guys, because there's only 5 of you, want to talk together, just the 5 of you? Well, there's 6 of you, but I'll let the 6 of you talk. I'm going to mute you here in the classroom so you guys can talk together. You are so muted. And you guys here in the class, talk it out a little bit. You guys doing okay over here? Need any hints? Alrighty. Yeah, Max. Well, that's for the speed at which it hits the ground. So I think it's just a single number. No, I'm pretty sure that that's enough information. It would not be one of the components. Max, it would not be one of the components.
Well, I got an answer that was extremely wrong. You got
All right, we should be getting close, guys. Just editing something on Canvas and then. All right, so first, let's talk a little bit about the speed at which it hits the ground and the angle at which it hits the ground, since most of that information is already known. Meaning, we already figured out how fast it was going sideways, which is the velocity, the component of the velocity in the horizontal direction, right as it strikes the ground. It never changed when it was launched. On the other hand, we do need to figure out the y component of the velocity just before it strikes the ground in order to get the total speed. Now, the truth is, you don't have to do it that way at all. And for those of you who know a thing or two, you realize you could use conservation of energy and just figure out the speed immediately when it hits the ground. The car has kinetic and potential energy at the top. It's going to have kinetic and potential energy at the bottom. So there's absolutely no reason why you can't just figure it out from there. and that would save you time. However, the only way to get the angle is to know two components of the velocity. Either you have to know the absolute speed and the horizontal, or you need the horizontal and the vertical. Since we have to find a vertical anyways, seems like we might as well take the extra step and figure it out. Which, for those of you who remember taking my class last year, and that's, I know, a subset of you, you realize that you're actually using conservation of energy to find this answer. Vy squared minus Vy naught squared equals 2a delta x is a version of conservation of energy. So if you remember that from last year, excellent. If you don't, you're going to learn it all again this year. So Vy squared equals 2 times negative 10 times negative 2 plus 3.5 squared. And somebody cut me to the chase here and tell me how fast it hits the ground, the vertical component. 7.2? Keep them extra decimal places in your calculator. You're going to need them. Because if you want to get that angle, the only thing you've got here is tangent. That's the best way to find the angle. The question is, from where did you measure your angle? And I would expect this to be measured from the horizon, which is going to be the inverse tangent of 7.2 divided by 6.06. That gives you the angle relative to the horizon. If you don't understand, it puts this component here in order to determine this angle. That's the angle relative to the horizon. And that's just a little bit more than what, 40, it's 48, 49 degrees. Any questions about how to find the angle or that final velocity? We still haven't found the final velocity. So to do that, it's going to be 7.2 squared plus 6.06 squared to the 1/2 power. I don't know what that is, and I don't care that much. But I'm sure you guys have figured it out. So what's the number? Who got 9.4? Home. You got some head nods. That's good news. Not interesting. Just other questions that can be asked utilizing the information you've already been given. So now let's, yeah, go ahead.
Why did you find the velocity at the final? Like putting it to the 1/2 power?
I used Pythagoras just to get the total speed at the end.
Oh, okay.
So does that make sense?
So that's
I'm using the same triangle. I'm just finding the hypotenuse of that triangle.
okay. Yeah.
Now, the maximum height is different, and I want to talk about it separately because this is where you start to figure out whether people really know what's going on or not. And what I mean by that is we often have this idea that once we've done one of these problems, they're all going to be more or less the same. Finding where the maximum height is isn't on its own hard. It's understanding which of the things we've chosen to pick at our initial information stays our initial information. And some people have difficulty with this kind of change. We are no longer asking about anything that took place throughout the course of the entire motion of the object. So none of the stuff we've solved for before can be reused, except for maybe the components of the velocity. On the other hand, we added some additional information when we asked for the maximum height. The additional information is the fact that at the max height, the vertical component of the velocity is 0. So we can set Vy equal to 0. But we can no longer assume that the displacement's -2. We're not landing. We're looking for this displacement. Now, most of you did that just fine. But you also have to recognize that if you want where along the ground it is, you need to figure out when it reaches this height. That's how to find the horizontal displacement. And that's where I saw a lot of you faltering in that you just didn't know what to do there. But the thing that links these two sides together is still time. So finding out where along the ground it is, you still have to know when that happens to do so. Now, I don't want to spend a lot of time on this, but this is still just motion equation stuff. You've got those four pieces to figure out the time. So 0 equals -10 times t plus 3.5. Not too tough? Any problem with that? And then 0 squared minus 3.5 squared equals 2 times -10 delta y. What'd you get for this delta y, by the way? Nobody? Dylan? When you did the delta y, you got 2.6? I'm not sure what it is you're trying to tell me, but delta y from what we've written here would be from the top of the table to here. That would not be the correct answer. I don't know which one Dylan found because I couldn't hear him all the way. Go ahead, Amanda.
I got 0.6125.
0.61. And so, Dylan, you had already added the 2 meters to that. So you do need to figure out that when you asked how high it is above the ground, you need to know what delta y is actually providing you, which is just the displacement. It is plausible that some of you also recognize delta y by its definition is y minus y naught. So if you found that that equaled 0.61, well, y naught was 2 meters. That's where it is initially. So the answer would be 2.6 meters above the ground. And then you use the time to figure out where it is horizontally. Any questions about this one? Now, if you're struggling, you have just now seen kind of the full birth of what it is that I would expect an honor student or an AP1 student to do. Probably not an honor student, but definitely an AP1 student to do. We didn't do a lot of this kind of stuff last year in AP Physics 1, but I expect it in this class. It doesn't require any new information. New information is about to begin now, but this is the old stuff. So are there any questions about the old stuff that I can answer at this time? Okay, here's where I hit the pause button. With something that at least is in the wheelhouse of what we just saw, but is perhaps more appropriate for this level. And, football did start this week. So I know that because the bars all around my house were packed. Glad they're all being so COVID safe. I'm sure you guys were packed. I'm sure you guys were being appropriately distanced. On the other hand, I did see a lot of people at FSU at the game. They did not look like they were being appropriately distanced. So we'll see how that pans out for us in about 10 to 14 days. Luckily, we're opening up all bars tomorrow, or today. So yay. I'm not sure any actually closed near my house, but all right, so those are the goalposts. And let's see, Luke, you play football. Anybody else in here play football? Brett plays football too? Great. How high is the crossbar on the uprights?
No, it's not. It's probably about 9. Probably about 9.
No,
I can touch it. No, I can touch it.
You guys at home don't see that basically they just said probably about and they're arguing about it between a foot, 9 or 10 feet.
10 feet. 11 feet. 10. It's more than 10.
Luke, you're at least raising your hand.
10 feet.
Yeah, go 10 feet.
Look at that for 10 feet.
All right, they want to go at 10 feet. Fantastic. That's 3.3 meters, by the way. Okay, 3.3 meters. And let's say that you are, we'll go, this is 30 yards, a simple extra point kick, 30 yards away or so. So if I put that in meters, that'd be like 30 meters. So you hit the ball, and it's kicked at 35 meters per second at an angle of 50 degrees. Do you clear the uprights? If so, by how much? There are a variety of ways to solve this problem. Let's see which one you employ. But again, you're kicking a ball 35 meters per second, angle of 50 degrees, 30 meters from the uprights. Do you clear them? If so, by how much? Does everybody understand what the question is? Now, I'm not looking for the answer so much as how you did it. So when I ask, how did you get your answer? I'm going to ask you to explain it to the class. So take a few minutes or take overnight and